Alright guys, so 102, the product and quotient rules for derivatives. So basically, if you want to multiply two things together and take a derivative of that, then that's where this rule comes in. And then if two things are being divided and you want to take the derivative of that, that's where this rule comes in. Okay? So the product rule, it works something like, if you look at that first example, basically if two things are being multiplied, you do the box times the derivative of the triangle plus the triangle times the derivative of the box. So for instance, you have something times something else. I label one a box, I label one a triangle, just because sometimes it's easier to see it that way. And then I have my box, derivative of the triangle is just 3, plus my triangle, derivative of the box is just 2. And then you multiply it all out, and then you have your final answer. So for something like this is the derivative, and then sometimes we just want to, make sure that we simplify everything, okay? And then we'll talk about the quotient rule in a little bit. So here's another box triangle. So box times the derivative of a triangle, which is really like a 1/2 power. So the 1/2 comes forward, and then to the negative 1/2 power, and then times the derivative of the inside, which is just 1. So times 1, we don't have to write it, plus the triangle times the derivative of the box, which is just -2. And then we clean it up a little bit, rationalize, final answers. Okay? A couple more of those product rules. So another one that's similar to B. So you have your box, you have your derivative of a radical, which is a 1/2 in front, something to the negative 1/2 power, times the derivative of the inside, which is 1, plus the triangle times the derivative of the box, and then clean that up a little bit, final answer. Okay, one more really similar. So this one is, here's my box, here's my triangle. So my box, actually this one should have parentheses. So box times the derivative of the triangle. Okay, so this is a 4th root. It's a 1/4 power. So 1/4 comes forward times blah, blah, blah to the power of 1/4 minus 1 is -3/4. And then times the derivative of the inside, which is just 1, plus triangle times the derivative of the box, which is just 1. And then again, you clean it up a little bit, rationalize, and then final answer. Okay. E and F are the last product rules that we have here. So for E and F, these are like really what we would do usually for product rule. Because something like this, we wouldn't normally do product rule. You would like multiply it out by foiling, and then you'd find the derivative. That would be much faster, okay? But for E, so you have the whole thing as your box, and you have your whole thing here as your triangle, okay, including the powers. So then you have your box, ignore the blue, okay. You have your box times the derivative of the triangle, which is 3 comes forward, and then blah, blah, blah to the power of 2, and then times the derivative of the inside, which is 4, plus, you still need to do your triangle times the derivative of the box. So the derivative of the box, the 2 comes forward, blah, blah, blah to the first power, times the derivative of the inside, which is 5. Okay, be really careful because on problems like these, for whatever reason, we like to stop here and be like, we're done, but we're not. So you have to do box, triangle prime, plus triangle, and then box prime, okay? Okay, in the next step, I tried to explain this to you in class, and that's where the blue marks are from. So what we're trying to do is we're trying to factor out. So a simple example of factoring out would be if you had 25x squared plus 100x, what can you factor out? What number can you factor out? A 25. What letter can you factor out? An x. And then this is what you get left. So factoring out something like this, easy for us. Factoring something like this, a little bit trickier. So I look at this and then plus all of that. So I look at my numbers first. There's a 3, there's a 4, there's a 2, and there's a 5. You can factor out a 2 and then change this 4 into a 2. So you're dividing away a 2, and I write that first. Here's my 2. And then I start to look at one of my parentheses. So there's 2 of these, and there's 1 of them here. So how many can you factor out? You can factor out 1. So if I write 1 out here, if I factor it out, if I divide it away, this one gets divided away, so I cross the whole thing out. There's 2 here, but 1 of them got divided away, so I just cross out my power. And then what's left is there's 2 of those, and there's 3 of those. So I can factor out 2 of them here, and 2 of them here, and I write them right here. So I factored those out, I divided them away. And then what's left is whatever's left. So I have 2 times 3 times 5x plus 2, which is 6 times 5x plus 2, plus, and then I have a 5, and then I have a 4x minus 1. So here's my 5 and 4x minus 1. Multiply that all out, add, subtract, final answer. Okay, so on your mini quiz 102, it's going to look, a lot of the questions, the answers are going to look like that. But then if you have, oops, sorry, you have to look like that. But then if you have to keep going and simplify further, then it's like that. Okay, so another example of that, and then this one you can kind of look through yourself. So you have box, which includes the 4 times this, and then you have a triangle. So box times the derivative of the triangle, and then triangle times the derivative of the box. Realize that when you take the derivative of 4 times x minus 1, the derivative is going to be 4, so you leave the 4. And then what's the derivative of x minus 1? It's just 1 plus 0. So 4 times 1 is 4. So that's why it's 4. Okay? And then from there, I do the same kind of thing. I'm factoring out and then simplifying. Okay? All right, and then it gets to fractions. So for fractions, you have to say this to yourself a couple times. You have to know it, all right, especially next year in calc. So the quotient rule, let's say you have a fraction with x's and stuff. So this looks complicated, but what you're actually doing is low d high less high d low, denominator squared below. I'm going to say it again. Low d high less high d low, denominator squared below. It rhymes. There's a low, there's a low, there's a low. There's 3 lows, okay? So it starts with low, it ends with low, it ends with low again. So here's what it means. Low, d high, less, high, d low, right? So the d is really denominator. So low d high, less, high d low, denominator squared below. So that's your rule. So over here, as an example, you have x squared over x squared minus 5, which cannot be reduced. So then you have low d high, so derivative of the top, less high d low, which is the derivative of the bottom, and then denominator squared below. So this is our answer, but then we simplify a little bit. So you multiply out the top, and then you get that. That's all it is. So again, low, d high, less high, d low, denominator squared below, multiply out the top, and then you get that. Okay? Okay, so 2 tricky versions on the back. So I did a lot, I used a lot of room, okay? So letter I. So here's another fraction. So low, d high, that part's easy, less high, and then the derivative of a radical. The derivative of a radical is going to be 1/2 comes forward, x to the negative 1/2 power, right? Because isn't this x to the half? So a half comes forward and then x to the negative 1/2 power. Okay, and then on the bottom, denominator squared below. So then you just have this x. Okay. From there, this is the answer, right here. This is the answer. From there, we're just simplifying, okay? I say just, but from there, we're simplifying. Sorry, there's like random pen marks Okay, so what I did first is I multiplied this part, no problem, and then I multiplied this in. So I distributed it in, and then that's why the 1/2 times 2 is just 1, and then I have x to the 1 minus 1/2, which is x to the 1/2, plus, and then I multiply, I get 7/2, x to the negative 1/2. And then I keep going, I multiply, so this is x to the 1/2, so 2x to the 1/2 minus x to the 1/2 is 1x to the 1/2, and then a negative times a positive is a negative. So I'm just going really slowly, showing all my steps, and then I get this, and then I change it into radicals, and then I, from here, that's a complex fraction. So you multiply the top and bottom by LCD, which is 2x. So if you multiply, you get 2x times this, and then you get 7√x, and then you get 2x times this. So final answer, or you can factor out the root x and you get this, which is exactly the same, or you can have two fractions, which is this, and these are all exactly the same. This one has a smiley face just because I think the book has this as the final answer, okay? But any of these are totally fine. Okay, there is something weird going on right here. This should be 4x minus 1. No, it was weird like that, okay? Well, I do. It's white out. Okay, so if you try one more time, give it one more time. Low-D, high, less, high-D, low, denominator squared below. Give it a try. Don't just copy. Give it a try. Try to figure it out. If you have a question, you can ask tomorrow. Or you can put it in the comments. Okay? All right. So there are your two rules. That's it. There's a product rule, and there's the quotient rule. Low-D, high, less, high-D, low, denominator squared below. Good, guys.